Today we're going to talk about the dot product, and the dot product is a way for us to multiply two vectors together. When we were adding and subtracting vectors together, we still had a direction component to it. However, when we multiply vectors together using the dot product, we end up with a scalar quantity. We'll go through some examples here. If I take the dot product of v and w, if I follow the formula says take the horizontal components of the two vectors, multiply them together, take the vertical components of the two vectors and multiply them together. So in this example, I would take 5 times -3 plus -2 times 4, and that would give me -15 and -8, which gives me -23. Similarly, we can take the dot product of a vector with itself, and that would just give me 5 times 5, so -2 times -2, which is going to give me 25 plus 4, or a total of 29. So you see we just get a scalar quantity that doesn't have direction. Some of the properties that go along with the dot product are stated here. We're not going to go too into detail about these. The most important ones being these first two, that you can do the dot product in either order, and if you do the dot product using 0, that also always results in 0. Now, what happens when we have two vectors? So let's say I have vector w, and I have vector w. They have an angle between them. We'll call that theta. And what that allows us to do, and I'm not going to go through the whole proof, but if I were to create a triangle here, I could then use the law of cosines to come up with the value for that cosine of theta. And what that would end up giving us is this. The cosine of theta is equal to the dot product of v and w over the magnitude of v times the magnitude of w. So we actually have two representations for the dot product. The dot product can be represented by just, if you have the horizontal and vertical components of your two vectors, you can just multiply and add. However, if you don't have that and you only have the magnitudes, you could rearrange this formula and it would give you that the dot product is the magnitude of the two vectors times the cosine of the angle between them. These two are synonymous, they're just written in different forms. So you have a couple of ways to find the dot product. It just depends on what you're starting with. So if I am asked to find the angle between two vectors, then I'm going to use the formula in this form. I'm going to say the cosine of theta is the dot product over the product of the magnitudes. And so the dot product is I'm just multiplying my horizontal components by my vertical components over the magnitude. Well, the magnitude of v, 3 squared plus -2 squared, so that's going to be 9 plus 4, or √13. And for w, remember that the magnitude is just basically doing the Pythagorean theorem. So I've got -1 squared plus 4 squared, so that's going to be √17. And that is going to give me the cosine of theta is -11 over, where's my calculator? If I do √13 times root 17. I end up with this funky decimal. So I'm going to keep that as a radical. If I were to just do 13 times 17, that just gives me 221. And I can leave it like that because, again, I'm eventually going to be finding the angle here. And this I can just actually put in my calculator exactly as it's written. If I just do second cosine of negative 11 divided by the square root of 221, that's going to give me my angle theta, which is about 137.7 degrees. Okay, so just a quick recap, when you're finding the magnitude, remember that the magnitude is really just the Pythagorean theorem when you think about it. If you were to graph 3i minus 2j, so that would be 3 minus 2, right? That would be this vector here. And that means I'm going 3 units this way and 2 units this way, right? So to find that magnitude, I'm really just doing, if you think of that as c, right? I'm just doing c squared is 3 squared plus 2 squared, and then I'm taking the square root of that. Right, so that's how we end up with the square root of 13 for that. Okay, vectors can be parallel, or they can be orthogonal, or they can be neither. Parallel vectors would be two vectors that are either going in the same direction or going in opposite directions. If they're going in the same direction, that means they're one vector on top of another. That means the angle between them is 0 degrees. If they're going in opposite directions, that means the angle between them is 180 degrees. So more importantly, if we go back to this formula up here, I know that the cosine of 0 is 1, and I know that the cosine of 180 is negative 1. So if I get either of those answers when I'm solving for the cosine, that tells me whether they're going to be parallel or not. If I get either one of those answers, they would be parallel. If they were orthogonal, and orthogonal is just another word for perpendicular. If they were perpendicular, that means the angle between them would be 90 degrees. And the cosine of 90 degrees is 0. And this tells us that the dot product would then automatically be 0. So the takeaway from that is this. If you have orthogonal vectors, their dot product is 0. Period. You don't need to do anything else. So if we look at this example, determine if the vectors are orthogonal. Well, all I need to do is the dot product. So if I have 6 times 1 plus negative 3 times 2, that's going to give me 6 minus 6, or 0. And because the dot product was 0, I would say therefore they are orthogonal. If we got something other than 0, that doesn't tell us anything other than they're not perpendicular. Okay, just because you get something that is something other than 0, that doesn't automatically mean that it's parallel. It just means that it's not orthogonal. Okay, that's it. Thank you so much. We'll see you next time.